Video 6 of Chapter 1. We are continuing on in our discussion on displaying quantitative data graphically. In the last video, video 5, we talked about how to display quantitative data graphically with dot plots and stem plots. And in this video, we are going to focus our attention on the histogram. Now, the histogram is a way to display quantitative data, but we have already talked about a graph that kind of looks like a histogram, but it displays categorical data, and that was the bar graph. Now, if you notice, both of them have these kind of bars approach to them, but bar graphs have gaps between the bars, and histograms do not have gaps between the bars. So there's a quick visual way to determine if something is a bar graph or if something is a histogram. But again, the main reason that there is a big difference between these is, again, bar graphs categorical data. And if we look down here at our x-axis, USA, India, UK, NZ, Japan, those are all countries. And so the categorical variable is by country. This is not quantitative. And histograms, which is the focus this video, video 6, is that it displays quantitative data. And so we're talking about, I don't even know what these numbers really represent here, but these are numerical values, and we could do some math with them. One thing to point out also in a histogram that the bins here, they must be of equal width. And so I want you to notice each bin can contain up to 50 different possible values, right? This thing just counts by 50, and we call that our bin width. All right. Now, over here in our bar graph, naturally these should all be the same width, but the width really didn't mean anything to the US and to India and to the UK and to NZ and to Japan. But the width in a histogram does have meaning. Now, I have seen students do this in their attempt of making a histogram, and everything looks good on the vertical axis. We got a label, we've got equal spacing, this looks nice. Our actual bins look like a nice histogram. There's no gaps in here, it looks beautiful. We have a label down here on the x-axis, but then people make it look more like a bar graph. You don't tell me what all the numbers are for each bin. Like, you don't have to tell me this first blue bin is for numbers between 0 and 10. All you have to do, so again, you don't do this. You don't give me these little intervals. Each line that is in here that separates, you're going to put a number right on that boundary line. So this would be where a 0 goes. This is the boundary line where 10 goes, right? Anything below 10 would go in here. Anything above 10 would go up in here. Now, the 10, what if you had a 10? That would mean 10s would go specifically in this one. So really, it's almost like you would say, this is 0 up to but not including 10. This is 10 up to but not including 20. 20 but not including 30. But again, this would the bin width would be by tens. We'd start at 0, and these are the numbers that you should really see to make this a true histogram. So please do not do these like range of numbers like this in a histogram. That looks more like something for a bar graph. All right, so I've got a data set. This is July 1st through 30th, 2017, the high temperature in degrees Fahrenheit in St. Louis, Missouri. And you might be thinking, are these just made up numbers or are these real data? I don't know. Why don't you go look it up if you don't believe me? So I'm going to show you two things here. I'm going to show you how to make a histogram by hand, which isn't always entirely necessary. And I'm also going to show you in this video how to make this histogram with your calculator. And then I will tell you at the end that really, if you want to make a histogram by hand, you could have the calculator do a lot of the dirty work for you. Okay, so we'll let technology help us out towards the end of the video. So first, to make a histogram, you need to figure out how many of those bins and how wide or what width do you need them to be. So if I'm looking at my data here, I might need to consider the range of values that I have. And I'm automatically noticing here, I got a maximum of 108 and a minimum, what is my minimum? I'm not seeing anything in the 70s, 80s, 84, I believe is my minimum number here. So I say here, ideally you want 5 to 10 bins right? These we're calling bins, and no, we don't need any gaps in here, but we want somewhere between 5 and 10 bins, depending on how much and or how spread out your data is. So I made this suggestion. How about we start at 80 degrees and we count by fives all the way up to 110? And you might say, well, okay, but could I start at 84 and go up to just 108 and count by fours? Sure, you could. But I think it would just look nicer if we had numbers that went by fives but started with a nice multiple of 10 value, like 80. Okay? So this is just my personal recommendation. I'm thinking starting at 80 and counting by fives until we get to the max of 108, which means we'll have to see a 110 at the very end. I think that's going to look nice. But again, there are kind of infinitely many ways you could make this, but there's only so many of those infinitely many that'll look nice and give you that nice like 5 to 10 or 5 to 12 bin range. So now I need to organize my data. So you notice I made myself a little table here. I set myself up for what the temperatures are going to represent. So these are the numbers that I'll actually see in my histogram. But really the ranges that I would see, that first bin is going to contain 80, 81, 82, 83, 84. So there's 5 numbers in there. And then 85 through 89 is 5 numbers. And 90 through 94 is 5 numbers. And remember, I'm not going to be putting this number like I just showed you earlier here. I don't want to do that type of thing. But this is just for me to organize my data. So I go through all my data and I count up the frequencies of numbers that are falling within each of these ranges, and I get all of these. Okay? So now my next step is I would need to make some axes. So I need a vertical and a horizontal axis. Whatever your data is related to, typically that will be the horizontal axis. It's not wrong technically to make it the y-axis, but whatever your data set is, I would typically make that your horizontal axis. So here's me starting at 80, and notice I didn't put 85 and 95 and 105, right? But I have the markings that would indicate that I'm counting by fives. I decided it would kind of look nicer if my numbers really only showed by tens. All right, so I'm not cheating by saying I'm going to count by fives, but then have my numbers count by tens. And I've got my label here to represent high temperatures, and then I just got frequency. How many am I going to have in each of those? So then my next step would be to actually draw in each bin. So the 80 to 85, I only had one value. It was that 84. So I go up to 1, come down, and 85 to 89, I had 6 values, come up, over, down. And so notice I maxed out here at 10. If you didn't know how far you were really going and you went to 12, well, that's fine. You can go up to 12. You just don't have any values up here. Okay, so consider your maximum Y value. It can be right at where you're going to leave off here, or if you wanted to leave a little bit of space up here, then that's fine. So there's our histogram. We just drew it in. Perfect. Now I want to show you something here. What if I didn't start at 80 and go all the way up to 110 and count by fives? Would my histogram look differently than this if I had started and stopped at different numbers or counted by different numbers other than 5? So I just want to show you 2 examples. Here's what the histogram looked like on my calculator, which you can kind of imagine that kind of looks like what I've got there. But here's if I started at 80 and went to 110, so the same thing that I just did here, but what would happen if I counted by fours instead of by fives? And does that really change the shape of the histogram? Does it look different? And it does look slightly different, right? I mean, if you notice down here, we get 2 ones, versus here we only had 1 1. So what happened is one of these values that was in this bin got knocked over into its own bin right here, and then here's still that 108 down the way. So it doesn't look terribly different, but it does look somewhat different, okay? And another example is, what if I had started at 84 and went to 108 and I decided to count by fours? Then here's what my histogram would look like. And does it look drastically different than really either one of these histograms here? And I would say, no, I don't think they look drastically different, but they do look somewhat different. I think this one looks more like our original histogram, but there is some slight variation. Okay? So just know that your histogram might look slightly different than mine if you started and ended at different values and whatever the bin width is or whatever you count by. All right? It might be slightly different. So now I've got a not really a question here, but a problem. It says to describe the distribution of high temperatures. And so I've already done some statistics in my calculator using my one variable stats. And I now have a nice shape of my distribution to go by here. And so first let's start with the shape so we can describe our socks. What shape might I call this distribution? It kind of goes up, and it kind of hangs up around here for a little bit and then kind of drops down. I think honestly you could go with one of two possible answers here for the shape. I could see some people saying this comes up, it kind of slowly eventually goes back down. It kind of looks roughly symmetric, right? It almost kind of looks approximately normal bell-shaped, but it's leaning just a tad bit to the left. So if you wanted to call it roughly symmetric or roughly approximately normal, I would be on board with that. I could see what you're talking about, especially if you just left it as roughly symmetric. Now, some people might look at this and go, I'm not really seeing too much roughly symmetric. I think I'm seeing more slightly skewed right. Because I got a stack of data here, and then it starts to go down and it slowly gets down there. And if you wanted to call it, say, slightly skewed right, hey, I would agree with you as well. There's no kind of wrong answer in terms of those two. It's up for interpretation. So how would I describe again? So I'd say the distribution, I'm going to abbreviate some stuff in here. So DISTRIB for distribution. The distribution of high temps, which I'll just say, is, and then you get to decide, did you think it was roughly symmetric or did you think it was slightly skewed right? I'm going to go with slightly skewed right. So is slightly skewed right with a, now in terms of center, I got to remember, if my distribution is skewed, and since I'm calling this skewed, I would want to use the median as the measure of center over the mean. If you call this distribution roughly symmetric, then it's up to you. Do you want to use mean or median? So it kind of depends on how you're writing this. If you're going to go with how I'm writing it, I'm going to have to use median as my measure of center. So here's my median, 93.5, with a median of 93.5, which is really 93.5 degrees if I wanted to put a unit in here as well. And I need to discuss a value of spread. And for spread, using median, I can either use IQR or range. Now, range you would use if there's no outliers present. I don't know if there are outliers present in this case. I could try to do my outlier rule. Do you guys know the outlier rule yet? I don't know. Ooh, that might not be until the next video. Anyway, so let's just go with range. We could use IQR, but let's go range. So range is going to be the max minus the min. So 108 minus 84 is going to give me what? 24? So with a median of 93.5 degrees and a range of 24 degrees. And so there's a description of my high temperature distribution. And again, if you wanted to use mean, if you thought the distribution was roughly symmetric, you could use mean. And if you used mean, then you need to use standard deviation, the SX number, as your spread. Okay, so just make sure your median or your centers and spreads match up appropriately with however you described it. All right, what does a histogram not tell us that we may want to know? And the quick answer is the actual data values. So if you were given just a histogram, if you were only given this and you were asked to identify, the minimum value, and you would look at this and go, well, there's one number that's in this bin, but the only thing I know is that it's between 80, but not including up to 85. So what is the actual smallest number? You don't know just based on the histogram. So it's kind of a downfall of a histogram is that you don't get those specific numbers, okay? And they can give a more precise center and spread compared to intervals of numbers. So we still get this nice idea of shape. Center you can still kind of approximate. It looks like the median would be about I don't know, somewhere in this ballpark that would split your data up 50-50. And then range is kind of difficult because you don't truly know what the minimum and you don't know what the maximum value is. So you don't exactly have a true range. You could say something like, well, I think the range is up to 30 degrees, right? Or at the minimum, the range, because you could have a number that's 105 that goes in this bin, and you could have a number that's almost 85 or maybe 84, depending if you do decimal values. So there's a difference of 20. So, I mean, you can say the range is somewhere between 20 and 30 just based off the histogram. All right, now let's talk about how to make a histogram, this particular histogram, in your calculator. And I'm going to use only the TI-8384 here. So I'm sorry if you have a TI Inspire, a Casio, whatever, an HP, whatever, but I'm only going to be referencing with the 8384. So step one, here's all of our original data again, and I put it all into a list. And that's how I got my statistics earlier, was using the one variable stats whenever I described this distribution. So if you're wondering where all that came from, I had already put my data into a list. So I've got all my data in a list, and then I'm going to press second y equals to get to the stat plot function. Okay, so if you go there, maybe not all of these are off, maybe some of them are on, but let's go to plot 1, and then what you got to do, it'll currently be on the off, so move it over to the on and press enter, so the little black background box moves to the on, press down, and we're going to go over here and select the histogram. So whenever you come down, then you have to press the right arrow pad to get over to here, press enter so that it selects it, and then you need to tell it what list is your data in. And so my list was in list 1, which is the default, but again, if you need to change it, you could switch it to list 2, list 3, whatever the case may be. Frequency, you're just going to leave alone, leave it 1. All that's really saying is we have one list 1, we don't have like 3 list 1s, and you might think, well, that's weird, why would you need that many lists? But just leave this as a 1. So after that, you could press graph, or you could press zoom and then go to option 9, or just press zoom and then press the number 9 and it'll shortcut to zoom stat, and you'll get a nice histogram that looks like this. Now, if you look at this histogram that I would get in my calculator and look at this histogram that I made earlier, they don't quite look the same. And so if you go up to the window button, which is up top on your calculator, it's right by the y equals button. If I look at the window, that'll tell me how everything's scaled in this histogram. And my calculator told me, and maybe yours would tell you this too, that the minimum value that it used was 84, and it went all the way up to a maximum of 112, and it counted by 4s. So when you see X scale, SCL, that's telling you the bin width. Okay, so X scale is the bin width. Now the Y minimum, it says they went down to negative 2.4. That's just saying that they left some room down here, just for room's sake. They went up to 9.36, which seems kind of a weird number to go up to, because you're never going to have a frequency of 9.36. And the Y scale, how much did they count by going up? They counted by 1s. All this other stuff that's down here, and I didn't truly show everything that the window would have, but XRes, leave it alone. You might see something that's like a delta X or like a triangle X. It'll have probably some weird, crazy decimal number. Just leave it alone. Don't touch it. So now we're going to talk about what would I need to change my window to so that it really looks like the histogram that we did by hand earlier. So I want to change my min and scale. You could leave the max if you wanted to, but I will change it as well. So in your window, change the min to 80, because that's what we said to start at. And let's make the max 110, because that's where I said to go to. I made my scale, my bin width, by 5s instead of by 4s. And then I kind of adjusted the min and max for the y-axis to still show me a little bit of room underneath the y-axis for space sake. And I knew I was going to go up to 10, so I made my y max 12, and I still counted by 1s. Now, technically, I counted by 2s, right? In my earlier histogram, it really doesn't matter what the y scale is, because I'm going to show you something that will accomplish that. So once I changed my window, and then I pressed graph, so at this point you need to press the graph button, and it'll resize it appropriately. So now the calculator's histogram looks, nearly identical to the histogram that I had earlier. Now, if you go up to the top, there's the Y equals button, there's the Windows button, there's the Zoom button, and then there's the Trace button. If you press the Trace button, which is over by the Graph button, then you're going to see a little cursor thing kind of blinking, and it's kind of hiding back behind here. You're not going to see it on this screen in particular, but it's really on top of the first bin. And there's this information that says min equals 80, max is less than 85. It's telling me that this first bin that's hiding back here, it has one value in it. It has a frequency of 1, and it includes all numbers 80 but less than 85. And then if I press the right arrow keypad, it'll take me up to my next bin. And so it's telling me in this bin are numbers 85 up to but is less than 90, and it tells me there are 6 numbers in there. The trace button's going to tell you the frequencies of each one. Well, that's kind of nice, or is it? We'll talk about it. Keep going. The next bin has 10, which matches up with what we had earlier for 90 to 95, and then 6, and then 6, and then finally 1. So I'm going to be honest with you here. With all those frequencies that I just got using trace and getting this picture from the calculator, once I adjusted my window, the easiest way, I think, to make a histogram by hand is not what I showed you earlier. By making a table and counting up frequencies, I would honestly use my calculator to do a lot of the dirty work for me. Put in all your data, make the window the way that you need the window with the X min and the X max and the X scale, and then use the trace button to know how many are going to be in each of those bins, and then pretend like you just made this histogram all by yourself without any technology. All right? So again, use your calculator to do most of the work for you here, and then all you have to come along and do is make yourself some axes with the appropriate numbers, give those axes some labels, and then, man, this is the spitting image of what was on your calculator. You can really cut out a lot of time here and really organizing through all your data. No, man, I went too far. What am I going? There we go. So here's what I want you guys to try, and you can do this by hand the long way. You can do this with your calculator and then kind of copy it onto your paper. But here are some SAT scores. And it says create a histogram with the following info. So I'm telling you specifically your window values and what your histogram needs to start and end at. I want the minimum number to be 1,000. I want to go all the way up to 1,600. And I want your bin widths to be 100. So everybody's histogram should look exactly the same because I'm telling you to use these 3 specific numbers. After you have your histogram, then I want you to describe the distribution of the SAT scores. And we'll see you next video.